So here you have graphs, etc. Then again, here what it looks intern, so in the IC chip itself, etc. pp. You need to read it, you need to understand it, and then you can draw the schematic. I don't want to go any details more. So here in the schematic, then you will make or import this chip. Yeah, probably there is already one you can just take. So the exact chip we just saw, so this BQ25, etc. And then you can load it in, or you need to create the own one. So in that case here, that it's not very, you just make here a I don't know, here such a rectangle, made the amount of pins it has. So from 1 to, I think it's 36, etc. Here is the last one. And you don't need to worry about the footprint. That's just the schematic. This is just an abstract function, description. Then you can load it here, put the pins with the correct functionalities, and then you can read the datasheet, and then you can draw the schematic. So here you can see input, a source here. So here you give the input voltage on it, so probably 70 volts. The 70 volts goes then in there and is powering the IC chip, etc. And here you have much more things, capacitors, etc. And these capacitor values are all described in the PCB schematic, in the IC chip schematic. So you don't need to figure or calculate this by yourself. You just read the data sheet of the chip, and there it stands. Okay, listen, 4.7 microfarads. Capacitor, ceramic capacitor, at it needs to be 10% precise. So 10% means this 4.7 microfarads, you don't have exactly those 4.7. There is a little bit of a upper and lower limit where it can be, and in this case it's 10%. So plus minus 10% of this value here it needs to be, and you can imagine if a component is more precise, it gets more expensive. Exactly. So then, as I said, I don't go into any details here. Just you will use the data sheet, place all your components, make the schematic, and then you should have a complete schematic of your application.